Assalamualaikum and very good morning. We are from Group 1. We will present about magnetic strength. So let's get started. Objective of the experiment is to measure the strength of a magnetic force. The problem statement is how many the magnet need to get to the car before the one magnet start to work together to pull the car along and minimize the distance. The theory is, if a magnetic piece of a steel rod is cut into smaller pieces, each piece is a magnet with a knot or a south pole. Therefore, magnet can be said to be made of lots of tiny magnets, all lined up with their north pole pointing in the same direction. At the ends, the free poles of the tiny magnets repel each other and fan out, so the poles of the magnet are around the ends. Magnetic force obeys an inverse square law with distance. The equation of magnetic force is similar to Coulomb's law, but the force is inversely proportional to the distance squared. Where r is the distance between the magnet, what that means in practical terms is the following. First one is, if the distance between two magnets is double, the magnetic force between them will fall to a quarter of the initial value. The second one is, if the distance between two magnets is half, the magnetic force between them will increase to 4 times the initial value. Then the third one, if the distance between two magnets is increased by 5 times, the magnetic force between them will fall to 1/25 or of the initial value. So this is the equipment that we had used to run out this experiment, which is the first one is magnetometer apps, the second one is toy car, the third one is ruler, and the last one is magnet. For a procedure, firstly we set up the racetrack, take a sheet of paper and tap it on the table. Then the second one is place a ruler alongside a piece of paper to make it as a measurement scale. Then take out one of the small magnet. The magnet should be the same size or smaller than a toy car. Tap it to the front of the car. Then put the car on the track. Set the car at the end of the ruler so that the front facing end of the magnet is lined up with 0 centimeters. Check a magnet and place another magnet at the other end of the ruler. Then start to move the magnet along the track. Stop after the magnet sticks to another magnet together. Then record the distance result. Repeat the step 1 until 6 with starting a new set of trial. Each time when added a magnet, which is 1 bar, 3 bar, 5 bar, 7 bar, 9 bar, and 11 bar. Remember to put the car back at the beginning each time. Then each of the trial, the magnetic field will be measured by using magnetometer. And the last one is take the average of the 3 results from each set of trial and calculate the magnetic force. This will show the strength of the magnetic field and give the usual distance that took for the car to start moving. Here is a video that we had recorded before. Okay, firstly, we had used 1 unit of bar magnet. We just on the magnetometer apps and pull the magnet alongside of the ruler until the other magnets stick together. Okay, then we had continued with 3 units of bar magnet. We just repeat the same step before. The third one is 5 units of bar magnet. Seven units of bar magnet. Nine units of bar magnet. Okay, then 11 unit of bar magnet. So for the result, we get it from the data collected from the magnetometer. So for each of the trial, we take 3 readings and take the average of the magnetic field and calculate the magnetic force by using the formula F equal to QV times B. So we just repeat with the different unit bar of magnet. So, we plot the data on the graph of magnetic force versus distance and state the slope of the graph. So, for discussion, from the experiment, we had used magnetometer to detect the magnetic field microtesla of the magnet. If compared to the result from the tabulated of the data, the magnetic field become increased when the unit of bar magnet are added each of the trial, but when 11 of bar magnet are stick together with another magnet, the value of magnetic force become decreased, which is 8.5 power of negative 25 if compared to the 1 unit of bar magnet, which is 4.42 power of negative 26. The magnetic force are calculated by using the formula F is equal to QV times B. Hence, the distance between the magnet that are start to stick another magnet together are slightly different. From plotted of the graph, the data obtained shows the curved line are not linear, so the magnetic force does not increase linearly. Then, slope of the curve are 0.882. So for conclusion, the theory states that if the distance between two magnets is double, the magnetic force between them will fall to a quarter of the initial value. As a conclusion, when the bar of the magnet are added, the magnetic force are decreased and the distance are become increased. So it shows that magnetic force are perpendicular to the magnetic field. So for application in daily life, most homes contain many magnets, refrigerators magnet, hot peppers, bottle openers, and other small items to the metal refrigerator door. And the second one is clothing magnetic tag, which is security tags are the first line of defense against the retail thief and shoplifters. So we had listed out few of the reference. And the last one is credit to our members. Nofahana Adil binti Basri, Intan Syazwani binti Mahazir, Nurul Najwa binti Ahmad Daham, and the last one is Nur Amalia binti Zahid. And to our beloved lectures, Dr. Izan Roshawati binti Mustafa. That's all from us. Thank you.